everyone. In today's clip, I will talk a little bit about bio-wearables and smartwatches. Just a reminder that anything I post here is not meant to diagnose or cure anything, and is for informational use only. For any health-related matters, please consult your healthcare provider. So smartwatches and bio-wearables are becoming more and more popular today. You're asked to imagine taking your glucose, hydration, stress levels, and even early disease markers without needles or blood tests. Bio-wearables are next-generation health devices that go beyond just counting steps. They continuously monitor biomarkers, meaning chemical signals in your body through sweat, interstitial fluid, or even light-based sensors. Think, for example, glucose, lactate, cortisol, blood pressure, heart rate, hydration, and a whole lot more. By the way, just to explain interstitial fluid, your body cells aren't just floating in air. They sit in a watery environment, and this fluid acts as a delivery system, carrying nutrients, oxygen, and hormones from your blood to your cells. It also helps remove waste products back to the bloodstream for disposal. It's basically the middle layer between the blood vessels and your cells, kind of like the buffer zone that keeps everything nourished and balanced. So going back to the topic at hand, here's how bio-wearables work. There are sweat sensors, which are flexible patches that use microfluidics and surface-enhanced Raman spectroscopy, or SERS, to detect molecules like glucose and urea. There's light-based sensors, which is Raman spectroscopy tech, which shines near infrared light on the skin to measure glucose or actually just glucose, no needles required. And then there's electrochemical sensors, which detect ions and metabolites for hydration and stress tracking. There is AI integration, and these sensors send data to apps that interpret patterns, predict risks, and give personalized sort of advice. So why does this matter? So continuous biomarker monitoring could mean, first of all, early disease detection like diabetes or kidney issues, stress and mental health tracking via cortisol, hydration monitoring for athletes, personalized nutrition and recovery insights. This could be a preventive healthcare at your fingertips. Now, there are some 2025 breakthroughs in bio-wearables, which include, there's something called GlucoWear. This is a trademark, by the way, which is the first non-invasive continuous glucose monitor with no needles and real-time data. There is smart sweat patches, which detects multiple biomarkers simultaneously. There are cortisol trackers, which is real-time stress monitoring via sweat, and AI health twins, which is wearables creating predictive models of your health. And of course, next up from here, which is being considered, are smart tattoos, implantable sensors, and wearables that talk to your doctor instantly. Your body will stream health data like sort of Spotify streams music, basically. Here's the thoughts on my side, and would love to hear from anyone on this platform, as I'm still learning about this subject. So bio-wearables rely on wireless communication, such as Bluetooth, Wi-Fi, sometimes cellular, and sensors that emit radio frequency, or RF, or electromagnetic fields, EMFs. These are non-ionizing radiation sources, meaning they don't directly damage DNA like X-ray, but prolonged exposure raises biological concerns. So the types of frequencies that they use include, as I mentioned, Bluetooth, which is around 2.4 gigahertz, low power continuous pulses. There's Wi-Fi, which is 2.4 to 5 gigahertz, which is higher bursts during syncing. There is cellular, which is LTE or 5G enabled wearables there are 700 megahertz to 6 gigahertz, and wave up to 60 gigahertz for 5G services. Then there is sensor tech, which is optical and electrical signals for heart rate, ECG, SpO2, bioimpedance, which is a way to measure how your body resists and reacts to a tiny, safe electrical signal. It's minimal EMF, but adds cumulative exposure. The documented health concerns about these have been, one, specific absorption rate or SAR and skin proximity. Now, wearables sit directly on skin, increasing localized absorption rate compared to phones that are in the pockets, right? Studies show higher SAR at the wrist for LTE-enabled watches and wave devices. Secondly, biological effects observed in research. When skin cells were exposed to very high-frequency signals like those used in 5G, they showed signs of stress, and basically the cells produced more harmful molecules called reactive oxygen species, which can damage cells if not balanced. This is like your body's defense system getting overwhelmed, which could lead to inflammation or aging effects over time. Now, also, this causes calcium channel disruption, which is when skin cells are exposed to certain wireless signals, the tiny gates that control calcium flow in and out of cells can get disturbed. Now, calcium is crucial for cell communication and health. Also, tight junctions, which act like seals between cells, may loosen. Now, this could make the skin barrier weaker and affect how cells work together. Next is the melatonin suppression. Wireless signals from devices like Bluetooth or Wi-Fi can affect our body's natural sleep cycle. Our circadian rhythm is basically our internal clock that tells us when to sleep and when to wake up. If that gets disturbed, it can lead to trouble falling asleep or staying asleep. So wearing smartwatches for long periods may affect the body's stress and hormone systems, as well as how your heart sort of responds to different situations. In simple terms, your body's control center for stress and hormones and your heart's rhythm could be influenced by constant exposure to signals from these devices. The World Health Organization says that the type of wireless signals used by devices like Bluetooth, Wi-Fi, and cellular might possibly cause cancer in humans. They are in the same risk category as things like very, very hot drinks or exhaust fumes. It doesn't mean they definitely cause cancer, but there is enough evidence to keep studying it. Because sleep trackers and similar wearables stay on your body all night, and they keep sending signals almost nonstop, that means your exposure to wireless energy is much higher than when you just use your phone occasionally. Some smartwatch straps actually have chemical called PFAS, which is nicknamed as forever chemicals because they don't break down easily and can build up in the body over time. Now combine that with the constant wireless signals from the device, and you've got two potential health concerns happening at once. So even though current research suggests low-level RF exposure from bio-wearables is within regulatory limits, with everything I just mentioned on my side, the jury is still out on whether I would trust a bio-wearable to monitor my health 24/7 or not. Let me know your thoughts. Hope this has been helpful. Like and follow for more. Be the light.